Yes, welcome to this video series. In this video, we will discuss about hypersonic air breathing propulsion fuel injection schemes in scramjet combustors. So, what is this scramjet means? It is a supersonic combustion ramjet engine. So, in this scramjet, the Mach number value is an 1 to 5. So the fuel injection of the scramjet engines, it's essentially in behind a tall and it's a narrow stream body, and the injection may be an axial, normal and angle relative to the free stream, and many shapes and angles of the injection have been investigated and experimented with gaseous fuel injection where upstream began to swept thin pylon with the various cross-sectional pylon shapes. The results showed much improved mixing and penetration, improved flame holding, and a lack of pressure losses and pronounced edge shocks. These results are not typical of earlier work referenced by Bork and Stanker, where an advantageous system of shaker from the pylon helped improve mixing but at the sacrifice of pressure losses. So the upstream injector, another type of fuel injection method is upstream injection is tested by it basically involves injecting the hydrogen fuel from the intake into the flow from portless upstream prior to combustion. This method is for a two-dimensional scramjet engine. The main advantage is this method as it that allows for a shorter combustion chamber. There's a reduction in screen friction drag. It has been determined that drag in the combustion chamber is one of the main contributors to influencing in scramjet. The injection point consists of four holes placed flush on the intake ramp as source is the 7. The proper setup of the ramp and intake allows for a combustor to occur in the combustion chamber with no burning in the free stream flow with the intake. So conventionally, the fuel is injected is a continuing stream injection ports into the combustion chamber where it ignites. This type of injection injects the fuel in a series of pulses, which allows for greater mixing between the fuel and the air. Combustion occurs more rapidly as well as more efficiently, thus producing a greater thrust output. The time between pulses is dependent on the free stream conditions and is coordinated to achieve near stereographic combustion. An advantage of this method is that combustion always remains in a transient state and never reaches a steady state condition. Transient combustion further enhances fuel air mixing as well as allowing for a greater depression of heat load on the combustor. The injector plate consists of a 4 by 8 matrix of injectors in this figure. The 8 port loads operate simultaneously at different intervals, and since only 8 of the 32 injectors are functioning simultaneously at a given time, the pulses can be of a lower flow rate. This reduces the need for higher pressure fuel lines since the position of the fuel injection ports consistently. In a micro flame holder designed for achieving ignition flame holding in a scramjet combustor has been previously built and tested experimentally by the Metanetial and all research papers. The microreactor igniter was constructed from copper and measured 15 centimeter in length and 5 mm in width with injector port diameters of 1 mm and 2.5 mm. Using a hydrogen oxygen mixture, and it experiment is holds about the Mach number of 2.5 air cross flow. This idea is to create a locally well mixed nearly stereographic region near the top of the pump that burns stably and deserve bedrock plant to ignite stabilize combustion in the combustor flow. The microburner array consists of three layers of top layer which act as a cover plate, middle layer in which fuel and air streams mix, and the bottom layer containing the fuel and air reservoirs. The major type of fuel injection used in scramjet technology is today are parallel and normal transverse injection, ram and strut and cavity pylon flame holder. Cavity flame holder or barrage injection is a pylon injection, upstream and pulsed injection. With these, there can be variations such as the use of a plasma igniter or cavity. Each method has its advantages and disadvantages. The main issue to consider in a scramjet engine is the flow speed, which has an effect on the mixing efficiency of the fuel and air. However, greater mixing can be achieved at the expense of a pressure loss. So this is the overall explanation of the fuel injection using the scramjet engines. So thank you.